So hey guys, I'm Jaydeep here. Today I'll be talking about how to classify most of the ML systems, right? So there are few criterias, and as of now, just understand these few basic terminologies because these will be very frequently used throughout your readings from the blogs or books or even watching YouTube videos or reading research papers. You will come across the various terminologies. So I'm just giving you basic idea. Don't worry. With the flow of the course, you will see these things in very much depth, and these will obviously become very natural to you. Okay. So the first criteria is that how much human monitoring is required. So these are the four types of algorithms, okay, which can be used for the machine learning. So the supervised is the one where we need to give data labeled, okay. So what I mean labeled. Suppose I am designing an ML application for the spamming of emails, okay. So in that case, in order to teach the system, what I will give is that I will give text plus its label whether this is spam or not, so that from combination of these my algorithm will understand so what kind of text should be labeled as what. Okay, so this is something called as supervised. It's just overall abstract idea. We will see much more in depth in the later videos. Okay, so next is the unsupervised. So what does unsupervised means is that in this case we are having just the data, okay, and nothing else. So from this the machine needs to discover the patterns by itself. So this is what called as unsupervised. Then we are having the semi-supervised. What semi-supervised means is that we are having labels but not for the total data. We are having the partial labels, okay. So this is what called as semi-supervised learning. Sorry. The last one is the reinforcement. This is one of the very popular technique. Okay, it's gaining much of a popularity, right? So this is where there are called as agents and environments, etc. So if you really want to see how much potential does the reinforcement learning has, just go and even on the YouTube you will find the video by the OpenML where um, machine learning breaks the hide and seek game rule. Okay, so hide and seek uh, game rule breaking. Okay, so this was something like that. It's very not very old, but yeah, decently old. So you can just see, type this hide and seek game rule broke by the AI. Okay, so you will get the first video. That's no problem there. So you will see that how the reinforcement learning is a game changer. Okay, now, given a particular algorithm, the main concern is whether it is online or offline. What does online means? Online means suppose your model is doing the prediction for a particular thing and new data came. Okay, so for this new data, how will you process this? How you will use this data for training the machine? Okay, so if you use the new data on the fly, right? So you are making predictions, some new data came and you are learning from that data also. It is what called as online learning, where you are learning from the data as soon as it arrives, right? So this might be the case in terms of web applications, right? So suppose new data came in and you want your model to upgrade according to the new latest data. So in that case you might need the online learning. A good example would be the stocks, right? If you want to predict the whether the stock price will go up or down, in that case the model must be able to process the new data as soon as it arrives, right? Otherwise it will fail. So in that case it is very much required that our model should learn from the new data as soon as it arrives. And the second one is offline or the batch. You can use any word you want. So in this case, if new data came, you just store that data. Okay, so you pile up the data, and after that what you do is that you train the model from the scratch. So it will have to learn everything from the scratch. Along with this new data, you can use the old data also, right? and then you will again do the deployment. Okay, so this is a little bit of a time consuming and takes many efforts, but it's fine if your model needs to be upgraded, say in a weeks or months or even in years. In that case, offline learning is good to go with, right? Now the third and a little bit more important criteria is that how do they generalize. Okay, so there, for generalization there are two approach. The first is memorization and the second is generalization. So what this means is that in case of an instance based, it is called as a memorization. So here what you do is that based on the past data you predict the new output. Okay, data of past. Okay, so you predict. Now this you can think of as an by hearting the rules or by hearting the data, right? So here you are not predicting anything new. Here you are just using the data you have previously saw to make the new predictions, right? A good example would be KNN algorithm. So what the KNN is does is that, suppose this is my axis for the feature 1 and this is for the feature 2, and or the x and y coordinate, I plot them like this, okay, and this. Suppose the new data comes over here. Okay, so this is my new data. Now in order to make prediction for this new data, what I might do is that I can take the average of the closest k people of it. Suppose I am taking 3 people, so this x and this x, these are the 3x which are very close to it. So what will be my output? My output will be the average of 3 values which I got from those 3x's. So in this case I didn't applied much of a maths. What I simply did is that what I have seen is previously I by hearted that and used that for my prediction. Okay, so this is the one case which is called memorization or instance based model, and the second or the method is called generalization, which is more popular. It can be like, see, this is our uh, prices for the house, and this is a area of a house. Now area in terms of square foot. So usually what we can see is that this goes like this. So as your price increases, most of the time area will increase. Okay, so what if suppose I said my price is this much. So in that case I know that the if the graph is linear, the area will be something over here, right? Now in this case we didn't by hearted the example, rather we learn from the example how to predict the data, right? So in that, using that idea, we learned that the uh, modeling is linear, so we can use the linear model to predict the area corresponding to the prices. Okay, so these are the two basic approaches, right? In the upcoming videos we will see more of an ML. So thank you, take care of yourself and take care of your time.